At first glance, the unit circle can be pretty overwhelming, especially when you're trying to memorize it. Because again, you're not going to have the unit circle available to you when you're taking a test. You're not going to have it available to you when you're taking the AP Calc exam if you're planning on taking AP Calc next year. So these are things that you want to have in your memory because you will have to evaluate things like the sine of pi over 4 or the tangent of 3 pi over 2 as you're solving a problem, and you're not going to have the unit circle readily available for you to reference. So when we're going through and memorizing it, the first thing is to always look at just this first quadrant. So if we look at the first quadrant, remember 1, 2, 3, 4. We know the original point, our starting point, is 0. We know all the way at the top we have pi over 2. So when we're looking at just the first quadrant, our first slice is the smallest slice, so that's where we get pi over 6. Pi over 6 is going to be the smallest slice of the circle because the denominator is the biggest. That means there's more slices in the pizza. The more pieces we make in a pizza, the smaller the slices will be. So we're going to go pi over 6. Then we go pi over 4 because we're getting a little bit bigger. Pi over 3. And our pi over 2. So this part you more or less have to memorize. This first quadrant you're going to have to memorize, but once you get the first quadrant, all of the other quadrants are just a pattern that we can use to fill in the values that we have. So we know we start at 0, we go pi over 6, pi over 4, pi over 3, pi over 2. Once we have our radian values memorized for our first quadrant, we also need to memorize our coordinates. So now the coordinates are 4 main coordinates of 1, 0, 0, 1, negative 1, 0, and 0, negative 1 are all just from traveling over 1, up 0, or respective to whatever the point is, how we traveled around the circle. We talked about that when we talked about how to read the unit circle. So those points are easy for us to go in right away and identify. The other coordinates are not as pretty. Root 3 over 2 and 1/2. Root 2 over 2, root 2 over 2, and 1/2 root 3 over 2. So when I memorize the first quadrant, the first thing I notice or that I tell myself is 2 over 2 is 4. So my pi over 4 has the coordinates root 2 over 2 and root 2 over 2 because I remember 2 plus 2 is 4. Then I looked and I noticed that root 3 over 2 and 1/2 is just the flip of 1/2 and root 3 over 2. So pi over 6 and pi over 3, which we saw they go together from when we were counting, they have very similar coordinates. Their x and y values are just flipped. And naturally, you would want the 3 to start with a 3, but nothing in math ever makes sense. So obviously, the coordinate that starts with a 3 goes with pi over 6. That's my fancy logic for remembering that. Or you could recognize that root 3 is a little bit bigger than 1. And if I looked at this, my distance, my x distance for pi over 6 is bigger than my y distance, so I need the bigger number to be my x value because my x distance is bigger. Whereas when I'm talking about pi over 3, now my x distance is the smaller one and my y distance is the bigger one, so I need the bigger number to be my y. So once I've gotten that first quadrant down, I notice all that happens is the coordinates for all of my denominators stay exactly the same, just their signs switch. So anytime I'm looking at, pi over 6. Anything that has a denominator of pi over 6, which are also the points that hug the x-axis, they all have a root 3 and a 1/2 as their coordinates. Root 3, 1/2. Root 3, 1/2. Root 3 over 2, 1/2. Root 3 over 2, 1/2. All that changed was that when I was in the second quadrant, my x value was negative. In the third quadrant, they were both negative. And in the fourth quadrant, my y value was negative. And this is true anytime we graph. If I'm in the second quadrant, I have a negative x value and a positive y value because I went back and up. In the third quadrant, I have a negative x and a negative y. In the fourth quadrant, I have a positive x because I moved forward, but I moved down, which gave me a negative y. So my numbers are going to stay the same, just depending on which quadrant I'm in is going to change the sign. So that's true for all of my coordinates. If I also look at pi over 4, I've got root 2 over 2 and root 2 over 2. When I go to quadrant 2, my pi over 4 becomes negative root 2 over 2 and root 2 over 2. In the third quadrant, they're both negative. And in the fourth quadrant, just the y value is negative. So the coordinates, once you get that first quadrant, you can just reflect your coordinates around the circle and change their signs based on which coordinate or which quadrant they're in. The other way you can remember where the radian values are is to think about it logically. So if I'm looking at the first quadrant, I only have one piece so far. So that's why I only have 1 pi out of 6, pi out of 4, and 1 pi out of 3. Once I get to the second quadrant, I'm one piece short of having a full pi. So if I'm slicing my pi into 3 pieces out of 3 would be a full pi, but I'm one short, so I have 2 out of 3. 4 out of 4 would be a full pi, so I only have 3 because I'm one short. 6 out of 6 would be a full pi, so I only have 5. Because once I get here, I have to have a full pi. So in my second quadrant, I'm always one piece short out of pi. So we want to be 1 pi short of a whole. So again, it's always going to be 1 less than whatever your denominator is. In my second quadrant, in my third quadrant now, I have 1 extra piece past a whole. So I've gone from the whole and moved and added 1 more piece. So we'll notice now I have 7 out of 6, 5 out of 4, and 4 out of 3. So this is 1 more pi. So 1 extra pi. And then in my fourth quadrant, I'm 1 slice short of having 2 full pies. So whatever double my denominator is, I'm just 1 short of that. So double 3 is 6, minus 1, 5. Double 4, 7. Or double 4, hello, is 8, minus 1 is 7. Double 6 is 12, minus 1 is 11. So this is 1 pi less than double the denominator. So even though it looks like it's a lot of information all on there to take in and memorize all at once, if you get just the first quadrant down, you can use that first quadrant and reflect it around the axis. The other thing to pay attention to, again, is that our pi's over 6's are the ones that hug the x-axis, whereas our pi over 3's are the ones that hug the y-axis. So remember, your denominators of 3 should be close to the y-axis, your denominators of 6 should be close to the x-axis.